Okay.
This
Hi.
call is now
Okay.
being recorded.
So today, as I said, we'll be going through questions for momentum and impulse as part of our preparation for the trial exam. So let's get on it. I'm starting from November 2023. So here we have a wooden trolley of mass 2.7 kg moves to the left at a constant velocity. This is the mass. So let me start marking my important stuff. We have the mass, then we have constant velocity, and then a bullet of mass 0.03 kg is fired horizontally from the left towards the trolley. That means it's moving to the right. And then a bullet strikes the trolley and comes to rest inside the trolley. So it stops in 0.02 seconds. The average net force exerted by the trolley on the bullet. This is by the trolley on the bullet, by the trolley. This is important. Is 591 newtons. Then the bullet and the trolley combination now moves to the right. Okay. So first of all, let's start with this. First question. Okay. Let me use a different pen. This is 4.1. So here they are saying write down the magnitude and direction of the average net force that the bullet exerts on a trolley. But here we are only getting that the average net force exerted by the trolley on the bullet is during this time is 591. So therefore, if we can remember our Newton's first law, that if you push an object, it pushes you back. So now, since the trolley is exerting this net force of 591 on the bullet is doing the same thing. Okay, so that means here we're going to have our 591 newtons to the right because it has direction. Please don't forget the direction because you might lose. But in this case, I don't think you might lose a mark, or maybe you might lose a half mark, whatever the case may be. Okay, but please remember. And then here in 4.2, they are asking to calculate the magnitude of the velocity with which the bullet strikes the trolley. Okay, so what they're actually asking from us is the initial velocity of the bullet, because here they said it comes to rest inside. There's somewhere where they say it comes to rest inside. So that means we already have our final velocity in that case, right? So we can use two ways to calculate this, but let's start with what I've taught last time we met. We have impulse. So with impulse, we have F net times the change in time equals to the change in momentum. Okay, so now that we have this, we have the net force, we have this resultant. This is the time. Then this is the change in momentum, right? The change in momentum we can calculate. Okay, change in momentum is this, which is the final momentum minus the initial momentum. And we already know that P itself is equals to m times v, right? This is our momentum. Okay, let's move then. That means here, since we have the force, we have the net force here. So what do we want? We want the magnitude that is exerted. Okay, the magnitude of the velocity, okay, which is phi. So here in this case, since the box here, the trolley is the one that is going to the left. So that means this force here is gonna go to the left, right? Okay, so that means here we can put our force and say negative 591 times time. The time is this one. The contact time is this one, which is times 0.02 seconds, then equals to the change in momentum. So the change in momentum would be, let me just extend from here what it would look like. So the change in momentum would be mvf minus mvi. We already have vf, which is 0, because the bullet comes to rest, right? So that means this, we are dealing with the bullet now, the mass of the bullet. So this is going to be 0.03 kg times vf. I said we already have it, so it's going to be 0 minus 0.03 vi, which is what we are looking for. Okay, so then we can now use our calculators to get our answer here. Okay, so this is 591 times 0.02. We have 11.82, which is equals to, this becomes 0. This is going to be negative, then now negative 0.03 vi. Okay, divide by negative 0.03, negative 0.003 goes away. Then now we have our vi here. Okay, this is gonna be 394 meters per second. All right, this is the magnitude. They said they want only the magnitude. If they said they want the magnitude and direction, then you'd have to say to the left, because this is the direction here. To the right, actually. This is to the right, then this is to the left. Okay? Coolies. Let's move with this question here. Does everyone understand?
Yes.
Okay, thank you. So then let's move. That means we are in now 4.3. So now they want the principle of conservation of linear momentum in weights. So this one, to make things easier for yourself, to always remember, you can say this is Pi equals to PF. So what this was saying, that the sum of all the linear momentum, right, in a closed, this is a closed or isolated system. Okay, this must be a closed or isolated system. The sum of all linear momentum remains constant. Okay, this is telling you if here it was 0, here it's going to be 0. If it was 1, it's also going to be 1. It never changes. It remains constant throughout. But then the system must be a closed system. Okay, or an isolated system. Isolated and closed, they're interchanged. Okay? Always. Then, lastly, 4.4. Now they want calculate the magnitude of the velocity of the bullet trolley combination after collision. So now they want the velocity of this part. So since they've already asked us here, and we know we can use this to determine what this is, right? So that means what we are going to do here, let me pull this and say Pi is going to be equals to the sum of Pf. So that means the momentum here, this part, should be the same as all the momentum that is here. Okay? So let's carry on then. That means here, momentum, as we know it, is going to be mv. Now we need to separate, because in this case here, initially we have a bullet, then we have a trolley. All right? So we need to separate these things. Okay? So here, you can say this is VI. Let me put bullet. Then plus MVI, then trolley. Okay? Then should be equals to MVF bullet plus MVF trolley. Okay? So now, since here, this part here, in this part here, we know that now this is combined. So we can combine the mass. Okay? We can combine the mass and VF, this VF bullet and this VF trolley should be the same because now it's one thing. Okay? So that means you can end up with something like this. MVI bullet plus MVI trolley. Then this should be equals to, I said this is actually this M actually should, this is bullet, this is trolley, this is bullet, this is trolley. You should also distinguish it. So that means here it's going to be mass of a bullet plus mass of a trolley, all times VF. I'm calling this VF, which is this V and this V. It's the same. We are not combining those. It's the same because now it's one system here. Okay? So now we can substitute our values. So here initially, for the bullet, we have 0. Let's maybe use different color. We have 0.03 times what is the initial velocity of a bullet. It's what we have here, 394. Which is 394 plus the mass now of a trolley. This is going to be 2.7. Okay, times 2.7 times minus 3. Okay, so I'm sure someone is already asking themselves, why is now minus 3? So let's remember here, momentum is a vector. So that means it has magnitude and direction. And this is velocity, which is also a vector, has magnitude, which is 3, direction, which is to the left here, to the left, and to the left, we are taking it as negative. Okay? So let's carry on. Then that means here we can say equals to 0.03 plus 2.7. These are masses, so they don't have direction, they just magnitude. This is going to be VF. Then we can punch in our calculator and see. So this is 394 times 0.03. You have your 11.82 plus then 2.7 times 3 or times minus 3. It's going to have 8.1 like this equals to 2.7 plus 0.03. Okay, 2.73 VF. And then you can simply divide both sides by 2.73. 2.73. Okay, so let's see what is going to be our answer here. Divide by 2.73. So our answer then is VF is equals to 1.36 meters per second. Okay, this is it. Or you can write it as this so that you don't 1.36 meters times second, like so. Okay, that means that's it for this question. Do we understand what happened here? Okay, so we can move on. Let's move to another question. Let's copy this one. Actually, okay, it's fine. Let's put it here. So this is a little bit different from what we are used to. So please pay attention. Okay. So let's start. Question 1. Question 1. They want the conservation of linear momentum. I've already stated this, so you should know it. Okay. Okay, let's move. So here, I'm going to say it again so that it is embedded. Embedded. So 4.1, the minute you see this, write your formula. You can write it maybe on your question paper so that you don't forget. PF like this. Okay, so the sum of all momentum, or let me add linear momentum in an isolated or closed system remains constant. Right? It remains constant. Okay, so let's start with 4.2. So the question here says the trolley X of mass 1.2 travels at 8 to the east and collides with trolley Y of mass 0.5, which is initially at rest. Right? So we have two trolleys here. We have two trolleys. This is trolley 1, which is trolley X. This trolley is moving. Okay? This trolley is moving. So since this is gonna be 1.2 kg, then it's moving to the east. Let's say east to this side. Just gonna say east is this side at 8 meters per second. Then we have another box here. So this box here is at rest. It's not moving. So let me put this here, put this here. So here, this is 0.5 kg at rest. So that means V here is 0 meters second, right? Like this. This is box. This is Y. This is X. So then we can start now. Okay. Ignore all frictional effects. The velocity time graph below shows the velocity of trolley X before, during, and after collision with trolley Y. Okay. Now let's move. 4.2.1. Calculate the magnitude of the velocity of trolley Y immediately after collision. Okay. So what we can do, use this principle here, right? Because we've already stated it and we know. So I'm sure you have noticed that these questions, they are not changing. They remain the same, just like our principle here. So therefore here, that means we are going to say P I equals to P F. So that means they want after. That means they want this part, the final part. But we must start from the initial part. That means, let's say mx vxi plus my vy, not vx, vy, I. Right? So mass of y, velocity of y, mass of x, velocity of x initially. Then we're going to have mass of x, velocity of x final, plus mass of y, velocity of y final. Okay, we want of trolley y immediately after collision. We want this one here, this part. So that means we are interested in this v here. Okay, now let's move. For x, our mass is 1.2. Velocity initially is 8. Remember, they said it's moving, travels at 8 to the east. Now to the east, if we're taking east, it's east side, right? So we can let's maneuver and see what happens here. Okay, east, we are taking east as negative, right? So that means we need to put negative to our velocity here, because we're taking it as negative. Unless if we are taking east as positive, let's say if we're taking east as positive, then we can just put 8 here. So let's write here and say east as positive. The direction, we're going to take it as positive. Then we can move. Then plus, this is at rest. So let me write it. Initially, this box here, it's at rest. So it's going to be 0. Then final, we come back to our graph now, right? We come back to our graph. So this thing here, this is 8, which is our velocity. It moves at this speed, which is 8. But when you get to this 20.1 seconds, we see that the velocity starts to decrease. right? So that means here, this is the time of impact, actually. During this time where the velocity starts decreasing, that means this is when actually the collision had happened. Okay? And then for the final part, the final velocity of that collision is this one here, which is 4 meters per second. Okay? So that means here we're going to have our mass of X is going to be 1.2 times 4, right? Then all still going east. Okay? Then plus M 0.5 VYF. Then we can play with our calculator, right? So here we're going to have 1.2 times 8, which is 9.6, then equals to 1.2 times 4, which is going to be 4.8. Then plus 0.5 VYF. Okay, and this is like terms here. Like terms. So here this and this. So you can take 9.6 minus 4.8 equals to 0.5 VYF. So let's see, 9.6 minus 4.8 is going to be 4.8 equals to 0.5 VYF. Okay, then final answer is going to be, you divide both sides. So you're gonna divide both sides. Let me just move with it this side. So you're gonna have 4.8 equals to 0.5 VYF. You divide both sides. So this is 0.5, 0.5. Goes away. VF now is the 9.6 again, meters per second. Okay. Let's revisit our question. They said they want the magnitude only. So that means we are not going to put the direction. Okay. Now let's move again. So now, next question. They want the average net force that trolley X exerts on trolley Y during collision. Remember, I said this part here is the collision time. Remember, it's the collision time. So the only time we can actually get the net force when dealing with momentum, this is going to be 4.2.2, is when we have impulse, which is F net, the change in time, the change in momentum. Okay? So let's put this into test now. So the time here, the time is not 20.2. So the time is going to be the difference of this time and this time, because this is when the collision happens here. So that means we have to subtract this from this. This actually from this. So that means we are going to have, for your delta t, you're going to have 20.2 minus 20.1. And then you should get your 0.1 seconds. This is your time. This is when the collision happens. Remember, this time here is the time of contact. So it's when the collision had happened, right? And then let's move with it. And then here you have Fnet, which is what we are looking for, times time. We already have the time. Then we are dealing with which trolley? We are dealing with trolley X. Okay, so let's use weight. So the average net force that trolley X exerts on Y during the collision. Okay, please mute your mics. Thank you. Okay, so let's, okay, here we have the final velocity of Y, right? So this one is moving, Y is at rest at this point. So let's see how we can actually do this. Okay, so we're going to have momentum F, not momentum F, Vf minus mvi. So now my question to you would be, which box are we using here? Are we using trolley X or are we using trolley Y? Okay, so let's do this. Let's use both of them. Gonna use the first, let's start with trolley X, then we use trolley Y. Then we decide, you're gonna tell me which is the right answer so that you can see if you understand. So this is Fnet. I'm gonna use the same time. The mass, let's start with trolley X. That means I'm going to have 1.2. Then times, this is 4. To the east, we took east as positive. So this is traveling east. So there's no need to put our negatives. And then we have minus 1.2. Our V initial is 8. Then this is going to be 8 like this. So Fnet 0.1 equals to, let's see, 1.2 times 4, which is 4.8 minus 1.2 times 8, which is 9.6. Let's see here, 4.8 minus 9.6, get negative 4.8. Then we have the Fnet times 0.1. Divide by 0.1 both sides. This goes away. Then you have Fnet equals to, divide by 0.1. That means you have minus 48 newtons. Okay? But let's do also using box X, box Y. So this was using box X here. This is with, let me write it in red. Just say this is box X here. Then now let's play with, hi, can you
Vamos
please
a
mute your mic? Okay. So as I was saying, then here you have your box Y. Because when you are choosing box, you should be justified with your reason. You should have a reason. You don't just take any box. So here we're going to have Fnet. Going to use the formula is this here, right? Fnet 0.1 and then equals to the mass is 0.5. Now x at rest. No, it's not x, it's actually box y. So y was at rest, but now we calculated the velocity of y here. That means it's going to be this part here. Remember, we calculated it on this question. Okay, so that means here it's going to be 9.6, then minus 0.5 times, this is going to be 0. Okay, this is going to be 0. So now, here, what is our direction? Okay, so this is trolley Y. So this was pushed. So I'm sure it's gonna go to the east also. So this goes away. This goes away. Then now you have your F net times 0.1 equals to, this is gonna be the 4.8 again. So that means you have 9.6 times 0.5. So this is gonna be 4.8. Divide by 0.1, divide by 0.1. Then goes away. Then you have your F net here. Divide by 0.1. So we are back with 48 newtons. Okay, so you see, it doesn't matter in this case which box we have used, right? So here, they want only the magnitude. So since they want only the magnitude, there would be no need to put a sign. You can just put 48, right? But you have to be careful because in this case here, see in this case here, you have a negative. So you miss it, they get you wrong. Okay, so the magnitude is actually 48. Okay, then the last question here, they're asking us if the collision is elastic or is inelastic. Okay, so now let's go back to what I taught. So let me paste this here. So in case you were not part of the session, so here I was saying elastic collision. The minute you see elastic, you must know two things. The momentum is conserved. The kinetic energy is also conserved. Okay, for an elastic collision. Now, if it happens that the collision is no longer elastic, that means the collision is inelastic. So if the collision is inelastic, let me just put collision here, collision here. So that means here, Pi still going to be conserved, okay? But the kinetic energy is not going to be conserved here. It's never going to be conserved. Okay, this is how it's going to be. So now, here, we would need to prove that it is inelastic. That means we would need to prove that the initial kinetic energy and the final kinetic energy are not equal. Okay, so that means I'm going to take kinetic energy, Ki of, let's say, x, plus kinetic energy, I of y. Must not be equals to kinetic energy, F of x, plus kinetic energy, F of y, okay, of the y trolley. So we are just substituting here to get that they are not equal. So this is going to be your reasoning, or that's how you're going to choose which is which answer here. So let's say 1 over 2 for x, box x, it's 1, 1, okay, let me do this, 1 over 2 mv I, this is for x, squared, 1 over 2 mv I, this is for y, squared here, then equals to, not equals to, must not. We're just making sure 1 over 2 mv f of x squared plus 1 over 2 mv f of y squared. Then you can substitute here because we've already calculated everything that we needed to calculate. So once you have this, you can simply conclude and say, no, it is, or no, it's not. Okay? Now, let's see. Let's put this side. So that means, so I'm going to have my 1 over 2 mv ix squared 1 over 2 mv iy squared equals to 1 over 2 mv fx squared plus 1 over 2 mv fy squared. Okay, so now let's substitute. Z must not be equals to. This is trolley x 1.2. Velocity is 8 squared plus 1 over 2. What is velocity? What is mass is 0.5. Then velocity initially is 0 squared. Okay, this is, let's put it like this. Kinetic energy initially. So we can have an answer here. So that means we're going to have the initial kinetic energy being equals to 1.2 times 8 squared times 0.5. So here you have 38.4 joules. Okay, this is your kinetic energy. Then for F, this is going to be 1 over 2. Same, we start with 1.2. Then this is going to be 4 squared, which is final here. Remember for trolley X. Then plus 1 over 2, 0.5 times what is our final velocity for Y. It's what we calculated here. We calculated it all. There it is, 9.6. So this is going to be 9.6 squared. Okay. So KF equals to 1.2 times 4 squared times 0.5, 9.6 plus 0.5 times 9.6 squared times 0.5, 23.04. So this is going to be plus 9.6. So you see here we have our final answer for final as 32.64 joules. So that means the energy has been lost because compared to what we have here, it's no longer equal. So that means the sum of EKI is not equals to the sum of EKF, right? So therefore, collision is inelastic. Okay, it's inelastic. So that's it for this question. So we can go through one last question and then call it a day. Let's take this one actually. Okay, let's put it here. Do we understand what is happening and how is happening? You can give me a thumbs up if you are happy. Coolies, thank you. Okay, let's start with this one then. 4.1. Okay, let's go through our question. We have two trolleys again. So you can see that this is repeating itself. It's repeating itself, but you should know these things. They should be part of you. Okay, so we have two trolleys again, A and B, with mass 1.5 and 2 kg. So we have them here. They are held in a stationary point. They're held on a stationary point. Very important. Please, so what I recommend is that when you are doing questions, the minute you read a statement and you see keywords, please mark them. Right? So this is this. So that means here at this point, V is 0. Already I can get this for you. Right? This is 0 per second. Okay? Because it's stationary. That means it's not moving. Velocity is 0. Then it's on a horizontal frictionless track. There's no friction with a compressed spring between them. Okay? The trolleys are released and the spring takes T seconds to return to its natural length. The spring then falls to the ground. It's fine. Then trolley A moves to the left. Then trolley B moves to the right. So then up a frictionless plane, inclined plane, rising to the maximum vertical height of 1 point, which is this. It's fine. Now, let's start with answering the question that is being asked in this case. So here, they want something different at this point, but we know it. We know it. This is the trick here. This is the trick. The conservation. C conservation remains constant. Okay? So here, I've taught this before in one of our classes. So we said the sum is similar to what we just did. So the sum of the mechanical energy, that means initial mechanical energy, going to be equals to the final mechanical energy, right? So that means, let me put it in words, the total. So the total, so mechanical energy, how it's actually, okay, let's say the total mechanical energy, okay, in an isolated system. Please remember, the system is isolated, remains constant. So the keywords here for you that you must not miss no matter what: remains constant, isolated system, and then total mechanical energy, right? So the total mechanical energy, actually, total mechanical energy is equals to potential energy. Let me write it as AP plus the kinetic energy. That is your mechanical energy. So in this case, it means that, let me bring this back. It means that you're going to have AP plus EK, which is your initial point. This is initial point, and then equals to AP plus EK at final point, right? So this is your mechanical energy. So let's do this. Now, calculate the speed of trolley B at the bottom of the inclined plane. So they want it here, somewhere here. All right? They want of B. Let's use mechanical energy, what we just did here, right? So let me see how we can best do this. Okay, so they want the velocity at this point here, right? At this point here. And then it moves up to this point here. Okay? Now, let's think about it. How are we going to do something like this? Okay? So, let's do this. Let's say 4.2, 4.2 mechanical energy at the top should be equals to the mechanical energy at the bottom. Okay? The top, the bottom. Okay. So with kinetic energy, we have 1/2 mv squared plus mgh. This is our potential energy. Top equals to 1/2 mv squared plus mgh. Bottom. Okay. So what we are looking for is at the bottom, not at the top. So here we have 1/2. What is the mass of block B? Because block B is the only one that goes up. So block B is 2 kg. We have 2 kg. At the top, it's going to stop. So it wouldn't have a velocity. When it gets here, it's going to stop. So then it means here we can say 0 plus the mass is 2 kg times 9.8. 9.8 is G. G, gravitational acceleration. This is 9.8 meters per second squared. Right? It's constant. It's a constant, right? And then you have your height, which is 1.5. 1.5 meters. Must be equals to 1/2. Okay, let me just use a constant color. Equals to 1/2. No. 1.5 equals to 1/2 2 kg v squared. Then plus, this is here at this point, the height is 0. So we can put 0 here, but let me write it times 9.5. 9 and it's 9. It's 9.8, not 9.5. 9.8 all times 0. This part here. This 0 is the height, because at this point here, the height is 0. Okay, so this goes away. This also goes away. So now we are left with the 2. Let me write it like this. I have 2 times 9.8 times 1.5 equals to 1 over 2 times 2 v squared. This can go away. Then we can have v squared equals to, let's multiply this last part here. So it's 2 times 9.8 times 1.5, which is 29.4. Okay, root both sides. So therefore, your V final here, your V is going to be, let's say, where is it? This is going to be 5.42 meters per second. Okay, so this is how it actually works. Then write down the change in momentum of trolley A. Okay, change in momentum of trolley A. Let's copy this. Come this side. Okay, so we are in 4.3.2. Now they want a momentum from us. So they are saying, no, I'm writing a wrong question. It should be 0.1. So here they are asking us for the time, t seconds, that the spring takes to return to its natural length. Calculate the change in momentum of trolley B. Okay, that's the first thing. So this should be fairly easy. We know that MVF minus MVI. Okay, this is our change in momentum. You should know the formula. For which trolley? We want trolley B, which is 2 kg. So now we can say equals to 2 kg final velocity, which is the velocity here at this point, right? This is for the t seconds. Remember, please don't, this is for the t seconds, right? So the minute it goes up is outside the t seconds. So here we can say final velocity is what we just found here, 5.42. 5.42 minus 2. Initially, they were at rest. Okay, so they were not moving. So you can say this. Then P equals to this. Then let's see what our answer is. 2 times 5.42. 10.84. Okay, this is kg meters per second. Don't forget to put the units and then to the right. As you can see, the box moves to the right like this. Okay, let's see then. They want 4.3.2. Please mute your mic. Okay, so we have, now they're asking us to write down the change in momentum for trolley A. Okay, the change in momentum for trolley A. What would the change in momentum be? So remember, the momentum is conserved. The momentum should be conserved. So since it's going to be conserved, it's going to be of the same magnitude. But since A is going the opposite direction, so we can say the change in momentum is going to be 8.4 kg meters per second, but in opposite direction. Right? You can see from the 1 mark that they don't want calculations from me. Okay, coolies. Let's do the last part and call it a day. 4.4. Calculate the speed of trolley A after T seconds. Trolley A after T seconds. Okay. How do we calculate this then? So we already have the momentum here. We already have the momentum. So this is the change in momentum for trolley A. If I can use it minus VF, I, not F. So here I would have to be set to the opposite direction, which you can say negative 0.84 equals to the mass of A is 1.5. VF is what we are looking for, minus 1.5. Then here initially they were at the rest, right? So we can say it's 0. Okay. Then this goes away. We are left with 10.84 equals to 1.5 VF. Divide both sides. 1.5. 1.5. This goes away to 1. Then we have VF equals to 10.84 divided by 1.5. Then you have 7.23 meters per second. This is going to be negative. Then it just means they say calculate the speed. The speed, just this. So the speed, this has direction, this here. So the speed won't have direction. It's going to be 7.23. The speed has the same magnitude as velocity, but velocity has direction and the speed doesn't have direction, which is what we have here. Okay. This is how we can do it. There are multiple options you can use to calculate this, but at the moment we've used this. So you can use this as part of practice and then see how it goes for you. You can ask questions on the group chat and then we will attend to them. Okay. Thank you guys for the attendance. Think we can